Hi everyone, today let's solve the problem number 42, trapping rainwater. So what the question states here, basically, so we have been given an array of height. So here we have been given array height. Here you can clearly see here, this is nothing but the height of the bars, this one, right? So we have been given an array height representing the bars of different height. So accordingly with the question, so here this is nothing but 0 value 0 is nothing but this one, first one. 1 is nothing but this one, 0 again this one, and 2 is nothing but this one. So this is nothing but the height of different bars, right? So here we have been given array height representing the bars of different heights where the width of each bar is 1. So width here, this one, width of this one, every bar is exactly 1. So you don't have to worry about it, right? So entire one width, so width of first one, second one, third one, fourth, 5, so this one 6, 7, so this one every width I'm just writing the this one here, just giving value. That's it. So here we have been given 12 bars. Basically this one is having the height 0, 6, 2, 3, 6 are having the height 0 basically, right? So here you can clearly 6, 3, 6 and 0, the first one as well. This one index 0, right? So we have been given an array height representing the bars of different heights where the width of each bar is 1. We have to calculate how much water can be trapped between the bars after raining. After raining, we have to calculate how much water can be trapped within the this one between the bars after raining. And one thing we have to note down here. This one is very important. Water can only be trapped between taller bars if there are shorter bars in between. So waters can be trapped in between the taller bars only if there are shorter bars between. So this part is very important. Just keep this in mind, right? So here we first we don't have water here, right? So this one. So here to store, so we have 0 here. The water cannot be stored here for this one, right? This one is fine. So here water is stored, water can be stored, and this is fine. And here this will be considered as one unit. Suppose let's consider this one as 1 unit, and here also water can be stored, this one between this one and this one, right? So here you can say that why we are not storing the water here to this level, right? So here because we have the height for the fourth one, right? For the fourth bar height is nothing but 3 here. So if we are storing the water will get spilled to this one, right? Again this will go here basically, right? So water will get filled to this one and this will go here. So we cannot consider the water, right? So we can save the water till here, right? We can store the water till here basically. This is fine. So here this will be considered as 1 unit, this will be considered as 2, this will be considered as 3, this will be 4, this will be 5, and in between this one, uh, this one and this one, again we cannot store the water at this level because the height of this one is only 2. This particular one, this particular bar I'm speaking, right? So this one height is 2, exactly 2. So we can save the water only at this level, right? So this is 1, this is 1 unit, total 6 units, right? So total 6 units of water can be saved. So that's what the output that we got here as 6. So that's what they have said here. So I'll just read the explanation part out. So I hope this part is completely clear. So the above elements mag, this one black section they're speaking of, is represented by the array, this one. Again, they have given the same array here. In this case, 6 units of rainwater, blue section, are being trapped. I hope this part is completely clear. Easy to understand, right? That's what I explained till now. So this one, accordingly with the example 1 figure, you can just write out this one as well. 420325. Same, similar one. So I'll get the output 9 basically. 9 units of water can be saved. So that's what they're trying to say here. I hope the question part is completely clear along with the this one. What do you call? Uh, Examples. So I hope the question part is completely clear along with the examples. Means they have given us wonderful examples just for the sake of understanding, right? So I hope the question part is completely clear. Next thing what we'll do, so we will be going with the two-pointer approach, man. So we will be going with the two-pointer approach. So let's see how can we make use of the two pointer approach. I'll just explain this one while we write the code itself. So approach, so we'll be going with a two pointer approach. It's quite easier. So you'll understand it when we write the code basically. So, and what would be the time complexities for the code that we'll be writing? So here the time complexity would be big of n and big of 1, because one thing is we will be traversing through the array once using the two pointers. As I've said, we'll be making use of the two pointers, right? So, and the space complexity would be big of 1 because we'll be making use of the constant extra variables. Some variables, right? Left and right, whether it may be. We are just going with the two pointers here. So the space complexity would be big of 1. The time complexity and the space complexity for the code that we'll be writing would be big of n and big of 1. And now approach. So I'll just explain the approach during while writing the code itself. Now let's start writing the code. So let's do one thing. Initially, what shall we do? Let's do one thing. We'll be making use of length of the height everywhere. So let me initialize this one to this one particular variable. I'll just initialize n with height dot length, or length of the height. So this is fine. Let's initialize two pointers as well. Assign the value 0 and write to this one n minus 1. This is fine. So the next part is we have to find the maximum height from the left side, and also we have to find the maximum height from the right side. And also finally we have to go with the total, we have to find the total water that can be trapped when it rains, right? So for this one, let's go with int left max and initialize this one with the value 0, and let's go with the right max and initialize this one with the value 0 as well. And the final one here, so we need to calculate the total water that's trapped. So for that one, I'll just go with water trapped, and let me initialize this one with a 0 as well. So the next step here is, as we are going with the two pointers, left has to be always less than right. We know this, right? So I hope this part is clear. And while left is less than right, we can do one thing. If the first condition is if height of left pointer is less than height of this one right pointer, then what we have to do, water always depends on the left max, because this one height of the left pointer is smaller than the height of the right. So in while reading the question, so I said one thing: water can be only trapped between the taller bars if there are shorter bars in between. So this line, so I read this one multiple times and I said this one is very important, right? Water can be only trapped between the taller bars if there are shorter bars in between. So that is the reason here, if height of the left less than height of the right pointer, then water depends on left max, right? So again, within this if condition, let's write one more if condition here. Nothing but if height of left, if it is greater than or equal to left max, then we have to update the left max quite obviously. So I'll just go with left max equals height of left. I hope this part is clear, right? So else what we need to do, I'll just come here. Else what we need to do, we have to add the water that is trapped at left basically. Left is the shorter one, so we have to add the water trapped at left. So I can just write it in this way: water trapped equals water trapped plus left max here minus, so this one will be height of the left. So I hope this part is clear, right? So let me do one thing. So now we have to move the left pointer inward. So I'll just give here left plus plus. So this is fair, right? So next let's do one thing. This will be else part I'm speaking of. Means now we have already considered when water this one depends on the left max, and also we have already considered when water depends on left max. Now we have to consider when water depends on right max. I can just copy the same thing, and this one from line number 11 to line number 17 and make the necessary changes. Now we have time. We are not giving any interview or we are not giving any contest, right? So we can just type rather than copy pasting and making the changes, right? So here, let me do one thing. Let's write the simple condition. So here this will be if height of right this one, right? If it is greater than or equal to right max here, so then what we'll do, we have to update the right max. So I'll just go with right max equals height of right. So this is fine. We are just updating the right max, right? So here, let's write the simple else here. Nothing but we have to add the water that is trapped at right. Here in this case, in the else, uh, we wrote the code for adding the water that is trapped at left. Now we have to write the code for adding the water that is trapped at right. So this one will be water trapped equals water trapped plus this will be right max minus height of this one, right? This is fine. uh, so the final step here is right minus minus means we are decrementing the right, nothing but here we are moving the right pointer inward, right? So we are moving the right pointer inward as we are considering the water that depends on right max basically, right? So if we are considering the water that depends on the left max, we are considering it will be left, means we are going from left to right, right? So in that case we have to increment the left. So now as we are considering the water that depends on right max, so we have to move the right pointer inward, nothing but we have to decrement the right as we are going with the 2 pointers. So the final step here would be we have to return the total trapped water. In this case it would be return water trapped. So this is it, right? This is it for the code. So we have to finally return the water that has been trapped in the units, right? So here we got 6 for the first one. We have already discussed this one. The second one you can just try it out in the same way that they have shown for the first one. So we have discussed this one already, right? This is fine. So let me hit the run button. I hope this works. Let's see. So yeah, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases, man. Yeah. You can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities, right? For now this is it. Thanks for watching, guys.